Hey team, here's our objective. Explain the border of K-Ville and Q's location. Alright, now the border of K-Ville. Remember, K-Ville was an island and it had a border like this. Alright? And it had a border between the reactants and the products. Alright? Why is it shaped like that? Because this is reactants, the concentration, and that's the concentration of the products. And in K-Ville, the border represents potential K values. Okay? Now, if K is big, my concentration of my products is greater than my concentration of my reactants, and a lot bigger. All right? If K is small, my concentration of my reactants is a lot greater than my concentration of my products. So a really big K value would be all the way out here, all right? And a really small K value is going to be up here. This is K equal to like 1.2 times 10 to the negative 6. This is K equaled to like 3 times 10 to the third, all right? You're going to have a really different, lot of products, little reactants, a lot of reactants, and a little products. Now, this all is the same for Q, all right? And Q is going to have a similar relationship. You've got a big Q, you've got a lot of products. A small Q, you got not a lot of products, all right? Now, there's an interesting relationship that develops with Q and K. And it's best to look at it linearly. If I draw... I spelled products wrong. Okay, if I draw a line, and I put K on this line, let's going to put K right in the middle. So K is equal to 1. That means I'm going to have, at equilibrium, relative equal concentrations of products. That should be two reactants. And I said reactants and said products. Okay, so if Q is here, so Q would be less than K. Therefore, or ergo, feels so weird saying that word, the reaction, and I spelt reaction wrong, forward is going to be favored. And I spelled favored wrong. So you're going to turn some reactants into products if Q is less than K. All right? Okay, now let's do it. Like here's our K. All right, value. Let's say I've got this. I've got Q here, which means my products, concentration of my products are greater than my concentration of my reactants. However, my Q is greater than K. Regardless of this, this tells you that the reverse reaction is favored until my reaction quotient Q will be equal to K. Okay? So this like line here is like a visual for you to help remember when K is greater than Q, when Q is greater than K, reverse reaction is favored. And if Q, where is it, is less than K, the forward reaction is favored. It's not favored forward, the forward is favored. Okay, until Q equals K. All right, rock and roll. Thank you.